Okay, so now this last one, or last page I should say. Okay, so now in our number 29, we have to figure out again which one of these graphs is that equation. Okay, well first I know it's going down because of the negative in the front, so that means it can't be this one. This one's going up. And then also I know the vertex because this is vertex form and it's -1. Remember, x is a liar, or if this is +1, this should be -1, but then the number outside here stays negative. So which one has a vertex at -1 and -2? Well, this one does. This one does not, and neither does this one, so we know it's B. Okay, so now again, the first number in the front on number 30 is positive, so that means it has to go up, so it could not be D. Okay, and then we want to look at the vertex. This vertex, again, the number inside the parentheses, it's the opposite. It's not -1, but +1, or x is a liar, so it's negative, it's positive. And the number on the outside stays the same. So which ones have a vertex at 1 and 2? Well, this one does not, because that vertex is at -2 and 0. This one is at 1 and 2, so it could be that one. And it's not C, so it's definitely B. Okay. Okay, simplify. Okay. Now, I know your teachers probably all have different methods for this. The one I taught is the birthday cake method for you guys in my class. I'll show a few different ways. First thing is you want to break down the 12, and the way we do it is with the birthday cake method. First you divide the smallest prime number you can into 12, and that's 2. And then you get 6. Then I'll do 2 again. Then I get 3. And then the smallest number I can divide into 3 is 3 itself. Okay, and then I get my little birthday cake candle, or 1, because 3 divided by 3 is 1. Okay, so now what I do is every group of 2 of the same. Every group of 2 numbers that are the same, I circle them. For every single one of those groups you circle, you take one of those out of the square root. So what this is going to break down to is 2 times 2 times 3. I circle those, and then one of those comes out. So now I end up with 2 times the square root of 3. And the 2's basically cancel out. You just have 1 left over. Another way you guys might have learned it is that 12, you want to see if you can take out a perfect square from 12. And I know that 4 times 3 is 12. And then the square root of 4 is 2, so I can just basically cancel out and it becomes 2. Okay. Another way to do this is you take the 12 and you just break it down. Okay, I know 4 times 3 is 12, and then I can break down 4, that's 2 times 2. And again, circle at the end of the branches of your tree, circle groups of 2. And then you can do the same thing like I did with the birthday cake. Okay, different ways to find the answer and get the same answer. Okay, and the next one I'm just going to show my method. All right, so again, take the number inside and we want to break it down. The smallest number you can divide, smallest prime number. In this case, it would be 2, so we get 24. And if you notice, I'm building a birthday cake as I keep dividing. That's why we call it the cake method. And divide by 2 again, that's the smallest prime number. Divide by 2 again, and that gives us 12. Divide by 2 again, because that goes into 12. That gives us 6. Divide by 2 again, and that gives us 3. And then the last number the smallest prime number I can divide into 3 is 3 itself. And then I get 1, or what I call the birthday cake candle. Okay, again, circle groups of 2 of the same number. So here's one group of 2. Oops. Here's one group of 2's. Here's another group of 2's. So that means I'm going to take not only one 2 out, but I'll be taking 2 2's outside of the radical. Okay, or the square root. So now this is what it'll look like. Let's do it underneath the radical this way. So I broke it down. Now I have 2 times 2 times 2 times 3. I circle every group of 2 of the same number, and I take one out from each one. And once I take one out, the rest cancel. And when they come out, you don't add them, you multiply them. Now in this case, whether you add 2 and 2 or multiply 2 and 2, you get the same thing. But just remember, you multiply the numbers that come out. Okay, so now 2 times 2 is 4. And then what you have left over is this 3 on the inside. Okay, and that's what I forgot to mention, is that whatever number does not get circled, you leave on the inside of the square root. Okay, or whichever one does not have a common factor, okay, or cannot be, or whichever number you cannot take the square root of in this method over here. Okay, so we know that. And what I forgot is that after you do that, you gotta remember that we already started with 2 out here to begin with, so you're also going to bring that 2 down and multiply it times whatever you brought out of the square root. So now 2 times 4 is 8 times the square root of 3. Sorry, I almost forgot that 2 that was out there. And I always tell you guys not to forget the 2, and look at Mr. Osborne forgetting the 2. Shame, shame. Okay, so now with this one, when you have a square root on top of a square root, the nice thing about it is that you can combine them together. So this is also equal to the square root of 15 over 125. Okay? So what I can do with that is I can cancel out some factors here, because I can reduce that fraction inside of it. Well, I know that I can divide 5 into both 15 and 125. So I'm going to do, let's see, the 15 divided by 5, and I'm going to do 125 divided by 5. 15 divided by 5 is 3. And then 125 divided by 5 is 25. Okay. Now, what I can do is, when you remember, when you have a fraction inside the square root, you take the square root of the top and square root of the bottom. Okay, so I can't do square root of 3. There's nothing I can do with that. So that stays as is. But I can take the square root of 125, and that's 5. So I know that B is the answer. Okay. Now, when you subtract and add radicals, the inside number, which we call the radicand, the inside number has to be the same as the other one you're subtracting and adding with. Okay, so it just happens to be that they're both 3, so I can go ahead and subtract them and find the difference. And you do that by subtracting the numbers on the outside, the coefficients. So here it's 3, and here you can't see it, it's 1. So it's basically 3 minus 1 is 2, and then the radical inside stays the same. So it's 2 times the radical 3, or square root of 3. Okay? And again here, the numbers inside the radical are the same, and if they weren't, you would have to break down each one individually and then combine them. And so what I'll do is I'll just add the coefficients on the outside, and negative 2 plus 2, well, that's 0. 0 times the square root of 0 is 0. Okay, case number 36. Okay, now with absolute value equations, once you've isolated the variables, you want to isolate the bars, the absolute value bars here, and basically you don't want like a plus 3 over here, you don't want it 2 times 2 over here. And if that's the case, you can go ahead and split this into 2 equations. So I'm going to write it over here to give us more room. So you're going to split it into 2. So the first one will be the same as the original equation, except without the bars. The second equation will be the same, except the number on the right will become negative. And you basically just solve those 2 equations, and those will be your 2 answers. Okay, so first, I want the variables on the left, or the letters on the left, so let's subtract the 5 here. And the nice thing about these is that you're going to do the same thing all the way across. Okay, so now, negative 5r equals 5 minus 10 minus 5 is 5. And then negative 5r, and negative 10 minus 5 is negative 15. And then I'll divide to get rid of that negative 5, and divide by negative 5 all the way across. Those negative 5's cancel out. R equals negative 1, comma, and R equals negative 15 divided by negative 5, which is 3. Okay? And so that would be, A. this answer here. Okay. So now number 37. Okay, now here's the case, like where I was saying, that the absolute value bars are not isolated because I have this 9 over here. So let's get rid of the 9 first before we start splitting it into two equations. So we have to subtract it from both sides. Negative 8 plus x equal to 25 minus 9. When 25 minus 9, that would be 16. Now I can split it into 2. Negative 8 plus x equals 16. Negative 8 plus x equals negative 16. So remember, the second one changes. Okay, now here again, I'm going to get the x by itself, so I'm going to add 8. And the nice thing again is that you do it all the way across. These cancel out. X is equal to 16 plus 8, which is 24. And x is equal to negative 16 plus 8, which is negative 8. Okay, so that would mean C is our answer. Okay, solve each inequality and graph its solution. Okay, again, here, we'd use the same idea. Okay, with the absolute value of k, as long as the bars are isolated, you can split this into two. So the first one is going to be k is greater than 10, greater than or equal to 10. And then the second one, you're going to not only make the 10 negative, you're also going to have to flip the sign. Okay, so now, if I was to look at these graphs, which one says k is greater than 10 and k is also less than negative 10? So really, it's a little bit harder to look over here. I mean, you could just match it up actually. But it technically, if you're not looking carefully, it could be C or D. So really what's going to tell you the difference is the graph here in this case. So k is greater than 10. Well, that is this portion of the graph here. And k is less than negative 10. That's this portion of the graph here. You could quickly graph it over to the side just to double check. Negative 10 goes on the left. This 10 goes on the left. And now you're going to make a closed dot because it's equal to. And for k is greater than 10, that's pointing off to the right, so we'd shade it this way. And for k less than negative 10, that's going to the left. So then for sure, we know it's C. Okay, number 38, do the same thing. Go ahead and split it into two because it's already isolated. Okay, so we'll have b is greater than or equal to 2. And then again, not only is 2 negative, but we also flip the sign. Okay, so let's go ahead and just graph it on our own and then we can just match it up with the graph over here. So first, positive 2 goes on the right, negative 2 goes on the left. And it's going to be a closed dot because it's equal to. So for positive 2, it says b is greater than 2. So that means we're going off to the right because that's more positive. If b is greater, that means we're going in the more positive direction, okay, with our solutions. And for negative 2, it says b is less than, and less than is to the left. So they're separate. So you know this is an OR answer because they're not connected. They don't meet in the middle. Okay, so that, in this case, well, that seems to match up with this graph right here. Okay, for b. Okay, now number 40. Okay, now solve each inequality. Okay, again, do the same thing, just like we did before. Okay, so now we can isolate it right away because we can split it right away because there's nothing to the left or right. Okay, so let's split into two different equations. 10k plus 9 less than or equal to 31. 10k plus 9 greater than or equal to negative 31, because remember we not only changed the sign but also. Okay, so now let's subtract 9 to isolate that k. This goes away, this goes away. Then I have 10k is less than or equal to 31 minus 9. That would be 22. And then over here, I'd have negative 31 minus 9. That's negative 40. And 10k is greater than or equal to. And I'll just divide both sides by 10. k is less than or equal to 22 over 10, I can reduce that by dividing, let's see, 2 into both of those. So it'll be 11 over 5. And you guys probably already noticed, you can see that we already know it's a because it's the only one that has 11 over 5. And you can see that k is less than or equal, so that matches this. And then we divide 10 here, and k is greater than or equal to negative 4. And that matches this portion of that same answer. Okay? Okay, so now 41. Let's do the same thing. The absolute value bars are isolated already. So we can go ahead and split the equation into two. Okay, so now let's split it. Negative 6 minus 6n greater than 54. And then the same thing, negative 6 minus 6n, except switch the sign. And now that number becomes negative. Alright, so now what we're going to do here is add 6 both sides. It's negative, so that gets rid of the 6. Negative 6n greater than 54 plus 6 is 60. And negative 6n is less than negative 54 plus 6, and that's negative 48. And the last step here is to divide both sides by negative 6. Now here is a very important key step here. If you ever divide a negative number, that causes the sign, the inequality sign, to flip. So remember, anytime you divide by a negative, you will have to flip this sign. So now, again, these cancel out, but it's no longer greater than for this inequality, it's less than. 60 divided by negative 6 is negative 10. And then this one is less than, and so this one will flip to greater than. And negative 48 divided by negative 6 is 8. Okay, so first let's see if we can find 8 and 10, and the only one that has 8 and 10 is C. Okay, so I know for sure it's that one. Okay, and it matches, because you see n is less than negative 10, just like here, and n is greater than. Okay, and they're OR, but that's not really going to help us find the answer. Okay. Okay, so now zoom out a little bit. Okay, okay, so we have this equation, and the one thing we can find, two things we can find from this equation. One, if the number in front of the bars is positive, that means it goes up, and it is. It's positive 1. So that means it cannot be D. All right, so it has to be A, B, or C. And then we can also find out what the vertex of this absolute value function is. And it's going to be not negative 3, but positive 3 for the x and positive 2 for the y. Because remember, if it's inside the parentheses of the bars, and it's next to the variable, it's aligned to you. It's not negative, but it's positive. So let's look and see which one of these has that vertex at that point. Okay, this one looks like it is, and you might not be able to tell, but this is actually a 3 right here, because it goes 2 to 4, so that means between it, it's 3. Okay, so it's actually going to be C. Okay. Alright, now, exponents, what you guys have just got finished doing. Okay, so this first one, simplifying these exponents, you're going to, when you multiply, remember we add the exponents of the same variables. So first I'm going to start with the x variables. Let's say zoom in a little bit. With the x variables, I have 3, 3, and negative 2. So just add them up. 3 plus 3 is 6, plus negative 2 is 4. So I'll have x to the fourth. And then for the y's, I have 4. I have 4 and 2. So then I have y to the 4 plus 2 is 6. Okay? So which one of those is, it would be B, because that's the only one that has x to the fourth and y to the sixth. And then you're probably wondering, what do we do with the number? Okay, well we multiply all the coefficients, and here the only coefficient present is 2. So it's 2x to the fourth times y to the sixth. Okay, now for 44. Now, when you have a power of a power, or basically an exponent raised to a power, you're going to basically distribute that exponent to all the exponents inside. So here, when you multiply, you add them. Here, when you raise it to a power, you multiply it. And it's important to know that the exponent on this 3 is 1. If there's nothing there, it's just 1. And the exponent on this y is also 1. So now I'm going to distribute this 4 to that 3, so now it's 3 to the 4th, and 4 to this one, so now y to the 4th, and 4 to this 4, you multiply them, remember, okay, so now it's x to the 16th. And again, if you see parentheses with an exponent on the outside, you're going to multiply. If you just see exponents and variables being multiplied, you know you're going to add. Okay, so which one is it matched up to? Okay, well the only one that has y to the 4th and x to the 16th is D. Okay, and 3 to the 4th is 81, so that's confirmed. Yes, it's D. Okay. Last one. Oh my goodness. You made it to the end. Alright, so now when you divide variables, you subtract. Okay, so now it's simply just 2 minus, you do the top number minus the bottom number, 2 minus 1, and that's x to the 1, or simply just x, which we know is D. Okay, so just a quick review of those exponents. Again, in number 43, we were multiplying, so we added the exponents. 44, we were raising the exponents to a power, and you had a power on the outside of the parentheses, so you're going to multiply them. And then down here, when you divide, you will subtract. Multiply, we add, raise it to a power, we multiply, and divide, we subtract. Okay? That's it.